All right, so we're going to have a look at how to add and subtract fractions, and I suppose I'd better start at the beginning. If we have something like 2/5 and we want to add 1/5, then we start with 2 of something, we add another 1 of it, we end up with 3 of that thing. The most common wrong answer I would see is 3/10, where the person has added the 2 bottom numbers together, but this would mean we've got 3 of something new. But if we have 2 of something and add 1 of it, we have 3 of that thing. We're still counting our fifths. We have 2 of them, we add another 5th, so we have 3/5 altogether now. So what that's telling you is that if the denominator is the same, then adding the fractions is really easy. You can just add the numerator, the top number. So if the bottom number is the same, we can just add the top numbers, which means that if I want to do 3/7 plus 2/7, then my answer is going to be 5/7. I add the top 2 numbers together and the bottom number stays the same. Now that's fine when you have a question where you have the same number on the bottom, but what if I have a fraction question like 2/3 plus 1/6? Well, now it's trickier. I don't have the same number on the bottom, so what do I do? Well, what we're going to need to do is convert these 2 fractions into 2 new fractions that do have the same denominator. If you remember, we're allowed to multiply the top and bottom of the fraction by the same number, and that fraction is still going to be worth the same. And what that means in this particular question is that if I double the top and bottom of this left-hand fraction to turn it into 4/6, it's the same fraction as 2/3. But now when it's written like this, I can add it to 1/6 because they have the same bottom number. It's important to note this is the same question. This version of the question is the same as this version of the question. All we've done is made the left fraction look a little bit different. But now that they have the same denominator, I can add them together. 4 plus 1 is 5, and the 6's stay the same. But unfortunately, again, that was a fairly straightforward example where we could just double one of the fractions to make the denominator the same as the other one. Sometimes it's a little more complicated. If I have a fraction question that's 1/9 plus 2/5, let's say. Unfortunately with this one, there's nothing nice I can do to turn the 9 into 5 or to turn the 5 into 9. So I'm actually going to have to multiply both of these fractions by something to turn them both into a new fraction where they share the same denominator. So this time, my first question is, what number can I think of that 9 and 5 both go into? And to save you some thought, the answer is 45. 45 is the lowest number that 9 and 5 both go into. Now, what have I done to that 9 to turn it into 45? What I've actually done is times it by 5, because 45 is 5 9s. And if I've times the bottom of the fraction by 5, I've got to times the top of the fraction by 5 as well to make sure it stays the same fraction. And 1 times 5 is 5. So again, these two are the same fraction. We can do the same again over here. What have I done to the 5 to make it 45? I've multiplied it by 9. And if I've multiplied the 5 by 9, I have to multiply the 2 by 9 as well. So what we've done is converted our old question into a new question, which is the same. It's the same calculation, it's the same answer, but this one I can actually do. Because now we've got the same denominator, I'm going to have an answer that's out of 45, and 5 plus 18 is 23. So the answer is 23/45. Just sort of by coincidence, all of these questions I've done here have been adding fractions, but the rule is exactly the same as if you were subtracting fractions. So let's just do another one over here. Let's do 4/5, take away 3/4. See what we end up with. Again, the bottom numbers are different, so I need to pick a number that 5 and 4 both go into to turn these into 2 new fractions that do have the same denominator. So a number that 4 and 5 both go into, if you're really stuck, if you can't think of a number that they both go into, you can multiply them together. 4 times 5 is 20, so that's a number that they both definitely go into. In fact, that is what I did in my head when we did this 9ths and 5ths question over here. What number do 9 and 5 both go into? I can't think of one. Just multiply them together and you'll get 45, and that's a number they both go into. So over on this 5ths and quarters one, we found a new denominator that 5 and 4 both go into. Now I need to think about what I've done to each of these fractions to turn them into 20ths. So the left-hand fraction was out of 5 before. What have I done to make it into 20ths? I've times it by 4. And if I've times the 5 by 4, I've got to times the top by 4 as well. So there you go. 4/5 is the same fraction as 16/20ths. And now we do the same with the right-hand fraction. What have I done to the bottom number to make it 20? Times it by 5. So I've got to times the top by 5 as well. So this question that we started with is the same question as 16/20ths minus 15/20ths, except this one on the bottom we can do. 16 minus 15 is 1. So the answer is 1/20th. Okay, so what I'm going to do is put some questions up there for you to have a go at if you want. If you'd like to, you can pause the video here and have a little go at those. So pause it now if you want to have a try, but I'm going to talk through the answers. Okay, so this first one, 1/4 plus 5/8. There's a few different ways of doing this one, but quite like our early examples, I can just double the top and bottom numbers of this left-hand fraction and it will be in eighths, just like our right-hand fraction. So if I double the 1 and double the 4, now we have a question that we can answer straight away. 2 plus 5 is 7, so that answer is 7/8. Now you may have got a different answer because remember there are lots of fractions that are equivalent to 7/8. You might have got 14/16, for example, and that would be the same, but 7/8 is my answer. The next one here, we've got 6 and 10. Now, if I'm looking for a number that 6 and 10 both go into, I might pick 60. So let's turn them both into fractions out of 60. That means timesing this left-hand fraction by 10, turning the top into 50. And it means timesing this right-hand fraction by 6, which turns the top into 6. And then we just add those top numbers together to get 56. And finally, 3/4 take away a third. The bottom number, I'm going to pick 12 because that's a number that 4 and 3 both go into. Turning the left-hand fraction into 12 means multiplying it by 3 because 4 times 3 is 12, so I times the top by 3 as well. And turning the right-hand fraction into 12ths means timesing the whole thing by 4 because 3 times 4 is 12, so I times the top of the fraction by 4 as well. I've got 9/12 minus 4/12, which is 5/12. And that's it, that's adding and subtracting fractions. Basic summary, they need to have the same denominator before you can add or subtract them. If they don't have the same denominator, take your old fractions and turn them into new fractions that do have the same denominator. If you can't think of a number that both of the old denominators go into, which is going to be your new denominator, if you can't think of a number, you can multiply the bottom numbers together. That will give you one. Just like I did with the 4 and 5 over here. If you had a bit of a blank moment and you couldn't think of a number that 5 and 4 both go into, multiply them together to get 20. And then that can tell you what your new denominator could be. Right, hope that helped.